Hello, today we're going to continue our exploration of different forms of linear equations. As I mentioned in the previous video, there are actually three forms that you need to be familiar with. The first is slope-intercept form, y equals mx plus b, and then there's the focus of this video, which is called point-slope form. Point-slope form is y minus y1 equals m times quantity x minus x1, and the whole idea behind this is the form of equation we use if we know the slope and one point on the line. In slope-intercept form, we had to know the y-intercept. Point-slope form is a little more versatile because I can use the slope and any point on the line. It doesn't necessarily have to be the y-intercept. And just for future reference, we will also be looking at something called standard form. We're not there yet. We're just going to focus on point-slope form at the moment. So, without further ado, here is point-slope form. Y minus y sub 1, that's like y sub 1, this is called a subscript. So we read this y minus y sub 1 equals m times quantity x minus x sub 1. And just as with slope-intercept form, the y and the x just remain y's and x's. There's nothing mystical about that. But for the m, the x sub 1, and the y sub 1, we're just going to substitute in numbers. M is the slope, just like we're used to. And remember I told you this is used to write an equation if we know the slope and one point on the line. So that point is an ordered pair, an x and a y. X sub 1 is the x-coordinate of the point we know, and y sub 1 is the y-coordinate of the point we know. And so if you know those two things, the slope and the x and y coordinate of just any point on the line, you can build yourself point-slope form. So let's take a look at it kind of backwards from what we did there. Here I've given you two equations in point-slope form. And what we're asked to do is we're asked to find the slope and find the point on the line represented in the equation. So let's start with example 1a. And the first thing we can say is that the slope is 3. The slope is always this number just outside the parentheses. So the slope is 3. The point on the line is a little more tricky. Let's look at this. The point is going to be 5, 2. In the original equation, it's x minus x sub 1. So this number here, this negative 5, is actually the opposite of what the x-coordinate is. So since this number is negative 5, since it was minus x sub 1, x sub 1 would simply be 5. Same thing over here. This was minus 2, so the point is actually the opposite of that, which would be 2. We can look at part B as well. The slope is going to be this number right outside the parentheses. So in this case, the slope is negative 2. And our point on the line is going to be, or is going to have an x-coordinate that's the opposite of this, and a y-coordinate that's the opposite of that. So our x-coordinate is positive 2, the opposite of negative 2, and our y-coordinate is negative 3, the opposite of positive 3. We can also work on going the other way, that is, if you have information, a slope and a point on a line, you can write an equation for it. So the way it works is this. We start by just writing down our equation with nothing substituted in. And then what we're going to do is we're going to substitute in piece by piece these 3 bits of information that we know to get something that looks like this. And notice I've put these in parentheses. The 8 is in parentheses and the 4 is in parentheses. I've done that for a reason. We'll talk about that in a second. But first, let's get where these numbers come from. So the first thing I want to look at is this 5 right here. You'll notice if we look at these corresponding parts here, that 5 is the slope that we got from right there. So m, the slope, goes in right there. This 4 comes from right up here, the x-coordinate of the point that we passed through. And notice I said x minus and then put that 4 in parentheses. That's going to be important later. And then our 8 came from the y-coordinate. So I've just substituted those values in. Slope goes right there, x-coordinate goes right there in parentheses, y-coordinate goes right there in parentheses. And now what I can do is clean this up a bit. Now that I'm looking at it and I see y minus 8, I don't need those parentheses. And here I see x minus 4. I don't necessarily need those parentheses. And so it comes out looking like that. So I threw some extra parentheses in there at you. Let's look at why that is. If we look at part B, first thing I do is I write down my equation with no numbers, just like when you're doing the slope formula. Write down the slope first. And then I'm going to make all my substitutions. And let's look closely at this one. The slope of negative 3 goes right there. So I've just substituted in my slope. The negative 2 from the x-coordinate is going to go right there. And notice I've put it in parentheses so that I can very clearly see that I have x minus negative 2. There's two negative signs there. And with the y, it was 7, and I've substituted in 7 right there. Now that I have this, let's clean it up a little. Y minus 7, well, I can just get rid of those parentheses, but look over here. X minus a negative 2. When you have minus a negative number, that's the same thing as adding a positive number. And so when I rewrite this, I can write it as y minus 7 equals negative 3 times x plus 2. So again, that minus a negative, I can just rewrite as plus a positive. Finally, I might be asked to write an equation for a line from a graph. And if I want to do this, remember there are two things I need. I need a slope, and I need any point on that line. So for slope, what I would do is I would just pick 2 points. I'm going to go with the y-intercept of negative 3, and this point right here, which is 1, negative 1. And then what I'm going to do is just count rise over run to get from there to there. So I'm rising 1, 2, and then I run 1. So rise of 2 over a run of 1 means I have a slope of 2. Now let's take a look at substituting in a point for x1 and y1. I can use literally any point on the line that I want to. Now, this means that we could get very different answers for this. I'm going to use the point 1, negative 1. My x-coordinate is a 1, so I'm going to put that in right there. And my y-coordinate is a negative 1, so I'm going to put that there. And notice the parentheses, so that it's y minus negative 1 equals 2 times x minus 1. And now I clean that up a little bit, and I have y plus 1 equals 2x minus 1. And that would be my equation in point-slope form. So again, with point-slope form, I can write the equation of a line as long as I have the slope and any point on that line.